Howdy, y'all. I'm David,
And I'm Efe.
and we're both engineers on the Amazon Elastic Container Service Developer Experience team. And today we're going to be talking about how to build and deploy containerized apps with the new Amazon ECS CLI. So the new Amazon ECS CLI is a tool that the developer experience team has been working on for the past couple of months to help engineers and developers get started quickly with with deploying their applications onto Amazon ECS. But it also helps them grow and develop and is with you for the entire developer experience, from releasing to operating to looking at logs to debugging. And we're going to talk about how to use the ECS CLI today to take your apps to production. So rather than sort of talk about each of the individual commands and what they do and all the flags associated with them, we're actually going to do something pretty exciting. We're going to build a service on Amazon ECS today. So this is very exciting for me because these are demos, right? Like these are live. You're going to see me in a terminal running stuff, and we only have an hour. And so it's going to be really exciting to see what we end up with. But even though we only have an hour and this is going to be like a live demo, we're not going to just build a sort of simple starter service to show you like a hello world app running in ECS. We're actually going to build a well-architected service on ECS. So following all of our best practices and the guidance that AWS gives you on how to run a service. It's also going to be production ready. And by that, I mean, the services that we build are actually going to be something that we would be proud and confident holding to the AWS standard of like letting people use in real life. And, you know, we're talking a lot about containerized apps today. And what that means to us is like, one of the real powers of Docker and containers is being able to develop microservices easily. So the applications that we build today are actually going to be composed of several different microservices, and we're gonna build those. We also want to follow, like I said, best practices. So like what we would do if we were actually building this for real live production use. And for us, that means having multiple environments that our services are going to be running in. So we're going to build not just one environment to get our app up and running, we're going to build a test and a production environment. And with multiple environments comes sort of this idea of having to build a release flow. So today we're also going to wrap things up by wrapping our environments and our services in one continuous delivery pipeline. So that's a lot to cover today. It's a lot to do, and we only have an hour. But using the ECS CLI v2, it actually makes it super easy to do the right thing. And that's the goal, and we're going to show you how to do that today. So the service that we're going to build today is something called the ECS Kudo service. And so for those of you who don't know, the ECS CLI v2 is completely open source. So it's on our GitHub page, github.com/AWS Amazon ECS CLI v2. And one of the things that we love so much about working open source is just the constant feedback that we get from our customers. So whether people are saying like, we really like this feature, or hey, here's our use case and we think that this particular solution might help that, to even people submitting pull requests, being like, hey, like I saw that there's this bug and it was pretty easy to fix, so here's a PR. That kind of stuff, like it makes it so rewarding to work on this tool. And we wanted some way to reach back and say, hey, thank you so much for your contributions. So today, the service that we're going to be building is the ECS Kudo service. And it's a pretty simple little service. What it's going to do is there's going to be two microservices. Just an overview of our architecture real quick. We're going to have our front end service. And what this is going to be is sort of a little website that you can put someone's GitHub username in, and we'll show you all that person's contributions and the rewards that we've given that person. We're also going to have another microservice. This is going to be our API service. And what this is going to do is it's going to be the front end to our data store. It's going to be the endpoint for our GitHub webhook. So we're going to end up creating a webhook URL that we're going to put on our GitHub repository. And whenever someone makes an issue or sends a pull request on our repository, it's going to trigger a call to our API service. So we're going to have these two ECS services, and they're both going to be running on AWS Fargate. So no EC2 instances, nothing to manage. And they're both going to be fronted by one load balancer. And what that load balancer is going to do is when a request comes in, it's going to check the path. And depending on the path, it's going to route to the right service. So if the request starts with /FE for front end, it's going to be routed to our website, our front end service. And if it starts with /API, it's going to route it to our API service. So this is a pretty simple architecture. If it's all on one slide, and this is pretty much all the complexity there is to do. But as with most things in AWS, there's a couple of resources that you might need to provision to get all of this set up. So we have ECS, we have a load balancer, that two services. That makes sense, but we actually have to provision a lot more under the hood. So let's take a look at everything that we actually have to build in order to get these two services up and running with a load balancer in front of them. Wow, that's a lot. Maybe more than you expected. Maybe if you're used to AWS, this makes a lot of sense. But what we need is we need a VPC for our applications to run in. And that VPC has to have public subnets, private subnets, routing tables, internet gateways. Obviously, we'll need an ECS cluster with 2 ECS services. But we'll also need IAM roles, ECR repositories, a load balancer, target groups, route rules for our ALB, security groups, task definition, log groups. There's a lot of stuff we have to build. But, I think you can go through this and probably figure out how to get most of these resources set up on your own. It's a lot. It's a little more work than maybe you had hoped. But I think this is a reasonable set of resources that we'll have to create. Don't worry, in our demos coming up, you won't have to know about any of these things. The ECS CLI v2 will set up everything for you. But for now, we're just trying to set the scene, like all the resources that we'll have to manage in order to get a production-ready service up and running on ECS. So this is all the resources that we're going to need to get 2 services up in front of a load balancer. But like we talked about earlier, one of the goals that we're trying to do with this is to set up a service in a way that we would if we were building it for production use. And what that means is we're going to have multiple environments, right? So the first environment that we're going to have is we're going to create a test environment. And this test environment is the very first environment that our code sees. So if I want to update the front end or the API service, I'm going to deploy to our test environment. And our test environment, all the services and load balancers and all that infrastructure is located in US West 2, just because FA and I are in Seattle, so that's near us. And we're going to deploy all of that, our test environment and all of our services in our test environment to our development account. And that's really cool because FA and I have full administrative access to our developer account. We can go look at anything, we can tweak settings, we can play around, we can accidentally drop tables, whatever we want to do, we have admin access to our test account. And that's where our test environment is going to live. But, I tend to push some questionable code sometimes, and sometimes our test environment gets broken because I forget a semicolon, or my Go is very bad, or my Ruby is just not quite up to snuff. So we don't really want our customers using our test environment. Our test environment is mostly for us to run our tests on and make sure that things look good before we promote it to our production environment. And our production environment is what our customers will actually use. And our production environment is going to be in US East 1. We have a lot of contributors in Virginia and the East Coast. And it's going to be in our production account. And we're going to put it in our production account because our production account has really locked down permissions. So that means that FA and I we can maybe go in and read things, but we can't necessarily go in and delete our production tables and lose all of our customer data, right? So our goal here is that we're going to have our test environment that we deploy code to. Once we're happy with our code in our test environment, once we know it works, we're going to deploy it to our production environment. So I think this is a pretty standard best practice, having multiple environments to partition your code in. So they're exact replicas of each other, except it's just the order in which the code goes into each of these environments. But, this is great, but there's a little bit of an additional cost, right? There's resources that we talked about earlier. That was all for one environment. So now that we have our production environment, it doubles the amount of resources that we're going to need. So even if you understand all of these resources really well, like VPCs and networking make a lot of sense to you, you're an expert with ALBs, you understand how to do route rules, even if you understand it all, it's still a lot to manage now. Like the sheer number of resources that you have to manage is a little cumbersome, right? So even if we have these two environments and somehow we have a way to manage all of these resources, there's another problem that we have now. And that's with how are we going to release our code? And with multiple environments, I sort of talked about how The ideal flow is that I deploy to my test environment, and then once I am satisfied with my code in the test environment, I promote it to my production environment. But doing that by hand is really cumbersome. Like having to manually deploy from my laptop to test, make sure things are good, and then manually deploy to prod is error prone. And what we really want is some sort of continuous delivery pipeline taking care of that release for us. So for ECS Kudos, what we're actually going to build is a code pipeline. And that code pipeline is triggered from our GitHub source. So our API service and our front-end service are both going to be in GitHub. And what we want is every time we push to those GitHub repositories, it's going to trigger a build in code build. That code build is going to take our image, our Docker files, and our code, bundle it up in an image, push it to ECR. And once that image is in ECR, we're going to deploy to our test environment. Once our code's in our test environment, we can go play around with it, poke around, make sure the website looks nice, have our automatic integration tests run, our unit tests run. But once we're ready, we want our code pipeline to automatically promote it to production. That way, there's no human involved, right? Like I just want to do, as an engineer, I just want to do a git push and know that my code will make it out to production safely. Again, the cost of doing that, while that's like a best practice, is more resources. So we left off with 2 environments and all the resources involved with setting those up. And now with a continuous delivery pipeline, we have our code pipeline, our code build projects, our S3 buckets now to store artifacts in as they're promoted through our code pipeline. We need KMS keys to make sure our artifacts are encrypted. And now, since our environments are both in different regions and different accounts, we have to set up cross-account policies and cross-region policies. And even on my best day, setting up cross-region and cross-account policies is really tricky because you don't want to get it wrong. Like the cost of getting it wrong is that maybe you open up your account to someone who shouldn't have access to it, right? So they're really tricky and you really want to get it right. And it's just a lot to manage in order to get our best practices out. So the ECS CLI v2 helps you with this. It helps set up all these resources for you. It helps manage them. It helps give you plugin points to areas where you might want to change things, but it also helps just get you started and get you moving quickly and following our best practices and giving you the growth to become a world-class production service. So with that, knowing all the resources that we have to make, the architecture that we have to build for ECS Kudos, all of these things, let's actually start building something. So I'm going to hand it over to my friend Efe, and he's going to start building our API service.
All right, thank you so much, David. Like you said earlier, we're going to split up the responsibility. I'm going to build the API service, and David will build the front-end service. So I have a GitHub repository already set up for the API service. As you can see, it's a very small and basic application. I have my Docker file over here. I have a Go service written up. So the first thing that in our Docker file that we're going to do is build the binary for the service. We're going to run the binary, and we're going to expose port 80 so that it can accept requests. I'm going to switch over to the comfort of my terminal. Over here, I've cloned the repository, and I have the exact same set of files that I showed earlier in the GitHub repository. And from the root of my repo, I'm going to type ECS-preview. Cool. So we get the help menu for the ECS CLI, and it tells us that it helps us launch and manage applications on Amazon ECS and AWS Fargate. It has these commands that are underneath it. We categorize every single one of our commands. So we have the getting started commands, the development related commands. So these are more granular commands for every single one of our concepts. So you can manage your project, your environments, your applications. So David mentioned earlier our CD pipeline. So we can use the release commands underneath it, the pipeline command, and then some advanced configuration settings for the CLI. Since we don't have any applications up and running, I'm mostly interested in the getting started section and the init command. So what I'm going to do is I'm going to type ECS preview init -help to see what it does. It helps us create a new ECS application. That's exactly what I want, and it has all these flags underneath it. I don't really know what each one of these flags do or what they really mean. One of the design tenets that we have for the CLI is for it to be for humans first. So if we don't specify any of the required flags, the CLI will prompt for you and we'll have a nice wizard set up. So the first thing that the CLI does, it greets you with a prompt. It explains what the CLI is. Welcome to the ECS CLI. We're going to walk you through some questions to help you get up and started with an ECS project. And then it explains what a project is. It's a collection of containerized applications or microservices that operate together. So in our situation, my microservice is the API microservice. David's is the front-end microservice. They operate together under the ECS-Kudos project. So that's what I'm going to name my project. Cool. The next question that it asks us is what type of infrastructure pattern best represents our application? And by infrastructure pattern, we really mean the architecture of our application. So as was shown in the slides, we'll have both the front-end application and the API application behind the load balancer. That's the architecture that we're aiming at. So I'm going to choose the only option that we have right now in the CLI, the load balance web application. Eventually, we'll have more application types over here. Cool. The load balance web app. And the next question is, what do you want to name this load balance web app? If I want to get some more help about like what this question might mean, I can type question mark and press enter, and then the help menu will show up for the question. It says that the name will uniquely identify this application within your ECS Kudos project. I know the name that I want for my application. It's just API, so I'm gonna type API. Cool. The CLI automatically detects the path of your Docker file within your Git repository. It's at the root, and this is the Docker file that I want to use for my API. If I had more Docker files, maybe I want to deploy multiple applications, you would see more paths listed underneath here. So I'm going to choose this Docker file. Cool, and it starts creating the infrastructure for your application now. And the first thing that it's going to do is create the ECR repository for your application. So while this is spinning up, let's quickly go back to GitHub and take a look at what our application does. So I'm going to go inside the package directory, and we can see two files underneath it, the kudos.go and main.go files. I'll take a look into main, and I'm going to scroll down to our main function to take a look at the paths that we have in our application. We have two paths that are listed. So as David mentioned earlier, from the load balancer, the moment that a request comes that's under the API path, we want it to be distributed to our API service. So I have any post request from GitHub, API/contribution/GitHub will invoke the create contribution function. And then if I want to get any of the rewards for a particular user, I can make a GET request to API/kudos/the username, the GitHub username, and that will invoke the get kudos for user function. Finally, we have one more handler. At the root, we'll have our health check, which is very basic. It just responds with its status OK. So I'm going to switch back to the CLI. Cool. So you can see that it created the ECR repository for my application. And it says over here that it wrote the manifest for my API application under this path, ECS project/API/manifest.yaml. And our manifest file contains configurations like container size and ports. We'll take a look at exactly what this means in a second. The next question that the CLI asks us is if we'd like to deploy our application to a test environment. And the answer is always yes. We want to deploy our application to an environment. So I'm going to say yes. And while this is spinning up, like David mentioned, we'll have multiple environments. And the first environment that we're creating is our test environment. I'm going to switch over to the manifest to understand what the manifest is. And yeah, we'll take a look at it. So I run tree, and you can see that in our repository, we just created the ECS project directory. Underneath it, we'll have a directory per application. So every time that we run ECS preview init for a different application, you'll get another subdirectory. So when David will run FE, you can see that FE will appear, for example, underneath it. And then under the API directory, we have our manifest file. So I'm going to quickly take a look at what's under manifest. And the manifest file is really infrastructure as code for our application architectures. So we have a declarative format for a load balance web app. We're trying to represent exactly what are all the common knobs that you might need for a load balance web application. So these involve the name of your application, the type of this app. Under the image, you'll have the path to your Docker file from the root of your repository. the ports that's exposed in the Docker file. So we saw earlier that port 80 was exposed in the Docker file. So we have the exact same port that's listed over here. So if you had a different port that was exposed, let's say 8080, you would be modifying this value. This is the path from the load balancer that we want to forward all the requests to our service. And by default, this is the name of our application, so API. These are the other common knobs that you might want to tweak. So this is the size of your container, so CPU and memory settings. And then finally, how many tasks you want your ECS service to run for this application. By default, we default to 1. So in our test environment, we just want to have a single copy. But you could imagine that if you're deploying this to a production environment, you want additional redundancy, and you might want to bump this value to, let's say, to a count of 3. The way that you could do this is at the bottom, we have an environments field, and it allows you to override any of the fields that's listed above. So I could say environments, for prod, I can set a count of 3, something like that. So I'm going to comment this back. And some additional fields that we have is environment variables and secrets. So if you wanted to specify any additional environment variables or like secrets that are stored in Secrets Manager or AWS Systems Manager, you could do that. And we'll take a look into this pretty soon. So I'm going to exit the manifest file and go back to our CLI. You can see that it's setting up the test environment. And what it's creating is a VPC, the ECS cluster, the load balancer for your CLI. So we'll dive a little bit deeper into exactly how this looks like by switching over to our repository. So as David said, the CLI is open source. You can access it under github.com/aws/amazon-ecs-cli-v2. I'm going to go over here under our wiki page. And in our wiki page, I'm going to click under the infrastructure tab. And over here, we explain each one of our concepts, as well as all the resources that we create for you and why we create them. So we'll first take a look at the test environment. What does an environment mean and what it contains? The environment that we create is over multiple availability zones. So the first thing that we'll create is a VPC that's over 2 availability zones. And each availability zone will have 2 subnets, one public subnet and a private subnet. Since we chose a load balanced web application as our application type, we'll also create an application load balancer for you. And then we'll have an empty ECS cluster. So all the services that are created in the same environment for the same project, like the front-end service that David will build and the API service that I'm building, will be placed into the exact same ECS cluster. Let's scroll down and take a look at what the application stack will contain. Since we already created the VPC, the ECS cluster, the subnets, part of a test environment stack, the only thing that the application stack needs to do is really create a listener rule for the load balancer, a target group, and place your Fargate service along with all the permissions that are necessary in your public subnets. And finally, the additional step that the CLI does while setting up an application for you is creating the necessary resources for your pipeline. So as David mentioned, part of the CD pipeline resources, we need to create an S3 bucket and a KMS key per region that you want your application to be deployed to. Cool. And you can find all additional explanations for these on our wiki. I'm going to switch over quickly to our CLI, and you can see that the environment stack was created. And now it says that it's linking the account and the region to our project. This means that it's creating the KMS key and the S3 bucket for the pipeline. And while this is happening, I'm going to quickly switch over to console so you can see exactly all the resources that we are creating. I'm going to click over to CloudFormation. So there is no magic behind the CLI. You own every single thing that gets created. And the first thing that we do is creating a test environment, right? So this is the CloudFormation stack for your test environment. It starts with the name of your project, ECS kudos, dash the name of your environment, test. If I click over here and we take a look at resources, these are all the resources that was mentioned in the diagram. You'll have your ECS cluster, the target groups, security groups, all the networking related configuration that as an application developer, you might not want to necessarily deal with. The load balancer. The stack set contains the S3 bucket and the pipeline artifact bucket. So these are all the pipeline related resources that you would need. I'm going to switch over to stacks again, and I'm going to take a look at the CLI really quick. You can see that the next step, once we have set up our test environment and set up the pipeline related resources, we start building the container image. So since we already specified the path of our Docker file in our manifest, it starts building the container image over here. We have our ECR repositories ready from the previous step. And it's going to, once the container image is built, it's going to push the image into ECR. So while this is happening, I'm going to quickly switch over to the console, and let's take a look at our ECR repository, and the image should show up there eventually. All right, so we have the ECS kudos/API repository. We'll create one repository for every region that your application will be in, and the regions are determined by the environments that you create. I'm going to press on the repository, and there is no image yet. So that means that the CLI hasn't done building the image yet. And this step usually doesn't take too long. Our image is pretty small. And while this is happening, I'm going to switch over to ECS so we can take a look at the cluster. All right, so we have a single cluster that's created. So this was created part of the test environment stack, ECS kudos-test some cluster name. And we can see that there is no Fargate service that's up and running yet. And that's expected because the image is not created, and then the CloudFormation stack for your application is not created yet. I'm going to switch over here, and looks like the image is still building. In the meantime, one thing that we can do is that we can take a look at what are all the other commands that are available in the CLI. So I'm going to type ECS preview again, and I'm mostly interested. So like David mentioned earlier, we can create multiple environments, multiple applications. So if we take a look at environment, you can see that we have a way of creating an additional environment. So if I want to create a production environment, we can run ECS preview and init. I'll switch over to the CLI. Perfect. The image is finally done building. We pushed it to ECR. I want to validate that it's indeed there. I'm going to switch to the console, refresh this page. Great. So you can see that the image tag is the git commit SHA, the short version of it. Our image is pushed and size. Great. And then the service should still not be created yet. All right, so we don't have anything yet. So let me quickly take a look into CloudFormation, and we should see our application stack being created. Yes, so exactly like before, the pattern for the name of our stack is the project name, ECS kudos, dash the environment name, test, dash the application name, API. And underneath it, you can see all the resources that are being created. These are the roles that ECS needs, your task role, your execution role, all the listener rules related, target group related resources, a log group where we're going to store your logs for your service, and the ECS service itself. And that's under creating progress. So let's take a look at quickly under the ECS console. And we can see that the test API service has one desired count, and it has a running of 1. But our stack, the CLI is still not done deploying. So that's because the service is not necessarily healthy yet, and the health checks needs to happen. So to validate this, I'm going to type ECS preview space app logs, and let's take a look at what's happening right now. It looks like we had 3 health checks that happened. Health checks are okay. That means that the service should be healthy now. After 2 health checks, we say that the service is healthy, and we can see that it gave us the endpoint for the service, right? So we can access our service at this ELB generated URL under the path API. Let's copy paste this API. And now I'm going to look at if I received any awards yet. And as expected, no, I don't deserve any awards. I didn't create any issues yet in my repository. We didn't set up the webhook yet. So this is expected. So I'm going to go over to a random repository that I have, cool points. I'm going to create a webhook underneath here. So I'm going to scroll over to settings so that any new issues that are created in this repository will make a push request to a particular URL. I'm going to copy paste the URL that's needed, contribution. /GitHub. So we saw this exact same path earlier while we were exploring our code. I'm going to change the content type to be application JSON. I'm not going to set up any secrets yet. I'm going to say, send me everything. Cool. So the webhook is created. We're OK. Let's take a look at it. Let's create an issue. I'm going to say, hello world. Hello. And I'm going to submit a new issue. Great. So the issue is created. That means that if I check this again, perfect. You can see that it was super fast. It saw that like the username F.A.Karakos created a new issue, and then we have a contribution now. Great. But one of the problems that we have with this is that anybody can actually create issues, right? So you could be in a different repository, and as long as you put our webhook URL, the path, that means that you can get rewards. And we don't want that. We only want to scope the rewards to be for the cool points repository. And the way that we can do that, we saw earlier that there was a secret option for the webhook, and that's we want to specify a value there so that GitHub can create a hash signature for each one of our payloads. So I'm going to go over to webhook again, and we'll have to, I'm going to say edit, and I'll have to specify a secret. So I'm going to do that over here. I'm going to generate a random UID, and I'm going to copy that. Perfect. So I'm going to switch over to GitHub. I'm going to update my webhook with this UID. Great. But that means that now that I also need to update my application code so that it can actually validate the payload against this UID. To do that, we can do multiple things. You could have, for example, the secret stored in SSM or in Secrets Manager, and then the application code could fetch that secret and validate against it. In our situation, what we did is that we have an environment variable called webhook secret, which we expect the value for this environment variable to be the UID. And we'll let ECS, so we'll specify it in our manifest as a secret over there that will be stored in SSM. And then ECS will actually inject it, will resolve the value of the secret, and then we'll pass it on as an environment variable for us. So let me go over here to the CLI really quick, to the terminal. I'm going to put a new SSM parameter named GitHub webhook secret with the value of our secret. I'm going to push this. Great. It created the secret, the SSM parameter for us. And I'm going to go over to the manifest file, and we'll modify our manifest. So under secrets, I'm uncommenting this section now. We want to provide a secret. The name of our secret is going to be, really quick, the name of the SSM parameter, which was, I forgot. All right, GitHub webhook secret. Perfect. And then the name of our environment variable is what's in our code, webhook secret, right? So the key is the name of the environment variable, and the value is the name of the SSM parameter. Perfect. I'm going to save this. And the next thing that we need to do is we'll have to commit these changes, right? So we modified our manifest file, add GitHub secret to manifest. I'm going to save this. And then the next thing that I need to do now is deploy this application. So I need to change it so that we'll limit the secret is picked up by the application. And I'm going to do that by running ECS preview app deploy. Perfect. So it found a single application API, and it defaulted to the single environment test. And it's doing the exact same step again. It's going to build the container image. It's going to push this to ECR, and then it's going to trigger an ECS deployment. And the first thing that it's going to do, since we set up a size of a count of 1 for our task, it's going to double that. It's going to create a new version of the container image, of the container, of the service, of the ECS task. And then it's going to drain the old task. So while this is happening, I'm going to pass it over to David, and he's going to start building the front-end service.
Thank you so much, FA. That was a delightful API that you built. I absolutely loved it. FA is so good at writing backend services, and I'm really excited to build a website to front it. So he built this delightful cool points. He has this delightful cool points repository, and if you create an issue, it triggers his webhook. Now I am going to build a website that calls his APIs and displays a beautiful view of all the kudos and contributions that you've done and all the awards that you get from doing that. So what's really cool is since we're developing two different microservices, I can develop my front-end application in Ruby. I am 100% a Ruby person. And because we're developing these microservices, Effie can write his backend service in Go and doesn't have to use Ruby, and I don't have to use some strange Go templating language in order to build a beautiful website. So this application that I have is super simple. It's just a Sinatra application. It has a couple of just one view where you can see the awards that a certain person made, and a super simple Docker file that just bundles up this Sinatra app and runs back up. And what's also kind of cool, and maybe something that you didn't notice, is that I'm actually on my computer now. I have really cool colors. It's beautiful. It's my home. You know, like every developer's terminal is their home. And the great thing about the ECS CLI v2, as long as we're both connected to the same AWS account, everything will just work. So if I want to deploy this application, I can do it from, I can do the same exact thing that FA did earlier and just run ECS preview init. So this is really exciting. What's cool is that this is a little different than when FA ran it. So when FA ran it, it asked him, hey, looks like you want to create a new project, like what do you want to call it? But now since our accounts are, since both of our terminals are connected to the same AWS account, just because we have a profile configured that talks to the same AWS account, the ECS CLI knows that there's already a project that exists and asked me, hey, looks like you're trying to build an app. Do you want to add it to an existing project? I do. I want to create my front-end application to talk to FA's API app. So I'm going to say yes. So it's going to ask me, which project do you want to use? And since FA already created the ECS Kudos project, I'm just going to add my app to that. This is a front-end application, so I want it to be accessible from the internet. So I'm going to use a load balance web app 2. And I'm going to call mine the front-end application. My Docker file is in my root directory, so I'll just keep going. And amazing. So it's going to do the same exact thing that FA's app did earlier. It's going to create an ECR repository for my front-end application. That way, the API and the front-end have separate repositories. And you can see it created a manifest file. So I'm going to open up my code. And as you can see over here, this new directory was created. FA did a great job of talking about what exactly these manifest files are. But just to show you for funsies, it's the same thing. These load balance web applications, even though mine is a website in a totally different language, totally different architecture, it's still a front-end web app. So the knobs that we expose are the same. So if I see that like we need more tasks in order to scale because I'm using a Ruby app or whatever, I can change the number to 3. I can change the memory to be a gig instead of 512 megabytes. I can update secrets just like FA did. But just going back to my terminal, it's going to ask me if I want to deploy to my test environment. Now, if you remember, when FA said, yes, I want to deploy to a test environment, it sort of sat there, did a lot of work, it spun up a VPC. Now, when I press yes, it's going to be a little different. So since we're deploying to the same environment, the VPC, the load balancer, all of that already exists. So we're not going to create it again. We're going to share a lot of the same resources. And now, since the ECS CLI v2 already set up my front-end application ECR repository, it's going to push the image there, and then it's going to start a deployment to ECS. So just for fun, let's go take a poke around the console and see exactly what's happening. So as FA mentioned earlier, we use CloudFormation to manage all of our resources. So if I see the resources, I see 2 things happening. One is FA is developing on the side, and he's creating his prod environment. And I am deploying my my front-end application to test environment. And it looks exactly the same as when FA did it. Creates an ECS service, it creates a log group, all these listeners. And just for fun, let's go to ECS and see what's happening. Let's cook in ECS land. You can see that there's this one cluster, and now there are 2 services. So FA's API service and my front-end service are both in the same cluster. And this allows us to do a lot of really cool things. So just by namespacing these two services together, we can grant really specific permissions to things like what has access to these services, what are the IAM roles, what can they do? We can namespace it by sort of the cluster and the services that they're in. So if you take a look at what's happening, we can open up the task, and this is sort of ECS starting up our service. And you can see our task is running, which is super cool. So let's take a look at our deployment. And so going on, and this is because, as FA mentioned earlier, our application does health checks. So I am going to go back to my terminal in my VS Code, and I actually like to use my VS Code sort of as my hotspot when I'm developing. So I'm going to do ECS preview app logs, just like FA did. But now that there's two applications, there's the API and the front end, I can look at either. So this is super cool. So even if I'm experiencing like, if I make a request through my website and hits FA's API service, even though I'm not developing that app, I can still look at the API service logs. But I trust FA, so I'm going to look at the front end logs. And as you can see, our task is getting lots of health checks from ECS. ECS is making sure that our app is actually super healthy before we launch it. So yay, this is really exciting. Our API is up and running. So I'm going to copy this path. And if I look at, so my GitHub username is KohiDave. So if I look at my contributions, oh no, I do not have any. So this is no good. I want contributions, I want awards. So what I'm going to do is I'm going to go to FA's Cool Points repository. Here's the issue he created earlier, but he's not going to be the only one to get awards today, so I will as well. And I'm going to say ECS CLI v2 is so cool. And since I am a millennial, I am required to put emojis in everything I do. So let's leave a cool face. And it creates. And so what's happening now is that this will have triggered the webhook, the GitHub webhook, which will have called the API service. And now my website, which calls FA's service, if I refresh it, boom, it calls FA's API service and says that, oh, okay, KohiDave has one contribution, and he gets an amazing award, a beautiful participant award for anyone who creates one or more issues. So this is delightful. I love kudos. Let's keep going. Let's make Cool Points even better. So one of the things that I have noticed about Cool Points, I want to be a helpful, productive member of this project, the Cool Points project. So I've noticed a small bug, and that bug is cool is spelled incorrectly in the title. Everyone knows that it's cool. Is the actual spelling. So this will really help FA out, I think. Easy oversight. I'm so happy to help. And if I refresh my kudos page, it looks like I'll get another award. So now I'm a detective, and it lists all of my contributions. So cool was spelled incorrectly. I am so happy that I could help FA. So I could keep doing this all day. I could keep creating issues in FA's repository, and I would keep getting awards, and I think everyone would be like, wow, David, this is so cool. And they would be right. So that's really exciting stuff. I like that a lot, but I do have one question. So my application, if I run it locally, it works, but if I deploy it, it works as well. How does it know what FA's API endpoint is? So if I look at the kudos RB file, this is what actually talks to FA service. And so whenever I call contributions for a particular user, it's super simple. All it does is it creates a URL that has the API URL /API/kudos/user. That's rad, but where does this API URL come from? So in the same way that FA got his GitHub secret from an environment variable, I'm getting the load balancer URL from an environment variable. And so what this does is the ECS CLI knows that there's probably a lot of really common fields that you're going to need based on the environment that you're running in, and the DNS name of the load balancer is probably one of them. So that way I'm able to easily pipe it into my application. But I don't have to be in code to get these values. I can also look at them through the command line. So I'm going to run ECS preview app show. And you can see like, oh, okay, I am in the ECS Kudos app, ECS Kudos project, the front end app. It's a load balance web app. And you can see sort of the configuration for our test environment. I'm running one task with 512 megabytes on port 80. Here's the URL and the path of that URL. And here's all the environment variables that we pipe in by default. So for the test environment, where we pipe in the environment name, and that's test. So when we deploy this to production, this value will be prod. The load balancer DNS name, again, when we're piping this, when we set up a prod environment, it's going to be a totally separate load balancer, a totally different URL, but we're not going to have to update our code because the ECS CLI v2 pipes that in for us. So speaking of setting up a prod environment, FA tells me that he set up a prod environment while we were talking and deploying our cool website. So not that he's deployed his API to his production environment. I want to deploy my website to the production environment. And I could run ECS preview app deploy. And it would say, hey, which environment do you want to deploy to? Do you want to deploy to test? Do you want to deploy to prod? But like I mentioned earlier, I really don't want to have to go through all of this manual deployment, making sure I'm testing it and the flow, the order that I do the deployments is correct. So what I'm going to do instead of doing a manual deployment is I'm going to set up a pipeline for this application, for my front-end application. So to do that, I'm going to run ECS first. I know I'm going to need a GitHub token, so I'm going to do that. But now I'm going to run ECS preview pipeline, and it. So the ECS CLI understands sort of the shape of our application. It knows that we have multiple environments and that we're probably going to want to deploy to them. So it's asking us, when we set up a pipeline, what is the order that you want to do these deployments? So it says, hey, do you want to add an environment? And I sure do. And the very first environment that I want to deploy to is my test environment. So I'm going to select that. Now it's asking me would I like to deploy to another environment as well. I'm going to say, yes, after I deploy to my test environment, I want to deploy to my production environment. The source code for the ECS Kudos front-end service is on GitHub. It's kohidave/ECS Kudos FE. And since I've configured a remote origin for GitHub in my local workspace, ECS CLI knows that, and it's like, hey, what do you want to be the source of your code pipeline? I bet it's going to be the ECS Kudos front-end GitHub repo. It is. And now it needs a GitHub personal access token. This is just so code pipeline has permissions to pull from my GitHub repo. So I copied that into my buffer just a second ago, and I'll give it that. So cool. So a lot of things just happened. You can see that it created 2 new files, a pipeline.yaml and a buildspec.yaml. We'll dive into those in a second. But the ECS preview, the ECS CLI told us, hey, the next step that you probably want to do is run ECS pipeline update. This will actually build your pipeline for you. So before I do that, I'm going to add all of this ECS project goodness to my repo and ECS project. And I don't know how to use computers. And then I'm going to push it to my repo. Cool. So what I did is I pushed my code to GitHub. So you can see that my latest commit to my ECS Kudos application is ECS project fun, and it has the ECS project here. And the next thing I'm going to do is I'm going to actually run that command that the CLI suggested I do. So ECS pipeline update. So what this is going to do is it's actually going to set up my code pipeline. It's going to deploy it. And while that pipeline is being set up, let's take a look at the files that were created when we ran ECS pipeline in it. So the first file it created was this file called the pipeline.yaml. And this is a very simple file. I think like even if you didn't know exactly what a code pipeline was, you could probably guess what each of these fields and sections mean. So the first thing we have is the name of our pipeline. So this is useful when you're in the console. It is the name of our project and the name of our repository. The source provider. So our provider is GitHub, and I want builds to be triggered off of pushes to master, but maybe some people are using like GitOps or like GitFlow or some other branching strategy. So if you wanted to change it, so maybe you only did a release when a push is made to your release branch, you could change that here. And then finally, it's just the order of our stages. So first we go to our test environment and then our production environment. That's super nice. And what's cool about this is that in the future, if you add more environments, maybe you have a production environment per region, so maybe a US East 1 prod and US West 2 prod, you can add those stages here and just run pipeline update, and they'll be updated. So it looks like our deployment to our pipeline actually succeeded. So let's go take a look at that in the console. So I'm going to go to code pipeline. And you can see our pipeline exists. So this is the name of the pipeline. This is the pipeline that the CLI created. And you can see it's hooked up to our GitHub repository. This is the ECS Kudos front-end website. It builds a code build project that actually builds your application and broadcasts it to each of your environment's ECR repositories. And then once the build succeeds, it deploys to your test and your production environments. So what is it doing in this build stage exactly? Well, one of the other files that was generated earlier that we didn't look at was this build spec file. And so this is kind of interesting. There's a lot going on here. I don't really know what all of this is, so this is exciting. But essentially, these are all just scaffolding to make it so that the ECS CLI can put resources in your AWS account where CoPipeline expects them. And above that, beyond just that, you can actually change the build spec to run your own tests. So I can run my RSpec tests right here. I can just do RSpec run. FA, who's writing a Go application, if he set up a pipeline for his API service, he could run maybe make tests. I know a lot of Go people who like to use make. So I could update this to do whatever I want to make sure that I feel comfortable releasing my code to our test environment. And running your unit tests is a great option. So just looking at our CoPipeline, looks like our build succeeded, and it's deploying to our test environment. And then once that deployment succeeds, it'll deploy to our production environment, which FA set up. So I didn't have to do anything. I don't have to know anything about this production environment. It all just works. So this is super cool. And so what this means for me as a developer is that I can use the CLI now as a starting point and as a tool to look at my logs and do operations and sort of just check the status and health of my application, but I don't have to use it in my day-to-day life, right? I can just do git add and git push or git commit. Push, and my code will be released. Nothing else. This is my workflow now. And this is super cool because what this means is that if I wanted to, here are all the awards that you can get. If I wanted to change, say, the participant award to be Code Poet, for example, I think that is a more illustrative term. I could just save this, do a git add commit, and push, and CoPipeline will release it to all of my environments. Cool. So that's sort of the end of the demo. If you can believe it, in just this short amount of time, we set up a multi-environment, multi-service, continuously delivered, well-architected service. And just to recap real quick, let's go back to our slides. The ECS CLI v2 is available open source. Go download it now. It's in preview. We would love your feedback. If you like what you saw here, let us know. If there's features that you want, let us know. We're working on some really cool stuff. If you want to use the ECS CLI v2 to set up your own applications, all you really need are these three commands: ECS preview init, app logs, pipeline init. That'll get you going. That'll get you deployed. And we really look forward to hearing from you to see what you want to see in the ECS CLI v2. So check out our repo if there's any, to see what's coming. We have some cool stuff: service discovery, additional infrastructure, CDK support, all that good stuff. If you're interested in seeing where we're going, if you want to help shape the future of the ECS CLI, let us know. Thank you so much. This was a lot of fun. Special thanks to FA for building our beautiful API service so I didn't have to get my hands dirty doing backend work. And thank you all for listening.